Okay, this is by Avinash. If photons are massless, then why do they get affected by gravity? Brilliant question. I mean, these are the questions that our school teachers should encourage us to ask. So this is a great question. We know that photons are massless. Photons are packets of electromagnetic radiation. They are localized disturbances in the universal electromagnetic field, which is a field made up of electric and magnetic fields. So photons are localized concentrations of energy. And as we know, photons are massless. They contain energy. They have a wavelength. They have a frequency. And this frequency manifests itself in different colors: green, red, maroon, etc. And that's what our brain interprets as colors, these different frequencies. So photons are massless. They travel at the speed of light. And yet they are affected by gravity. Isn't that a great paradox? Gravity is supposed to affect massive objects. If I have a massive object, I let it go, it drops to the ground. That is the force of gravity. But we find that even light is affected by gravity. Even the trajectory, the path of light itself is bent by gravity. How on earth does it happen? So there are two ways of looking at it. Let's look at it first from the perspective of general relativity, which is geometrodynamics. It is it is the dynamics of light and energy and mass, or mass, energy and light, in the arena of four-dimensional space-time. So wherever you have a mass, it's going to warp space-time, it's going to curve space-time, and anything that travels in a straight line will be forced by this curvature to travel in a curve, because the fabric of space-time itself has curved, it has warped. And that affects light too, because light also travels within space-time. It cannot travel outside of space-time. So since space-time is curved by a mass, even the trajectory of a light beam would get curved because of that. So that's the simplest way of looking at why is light affected by gravity. The other way of looking at it is to look at it from the perspective of quantum mechanics. Now, the most famous equation in the world is E equals mc squared. Every mass has an equivalent energy, and every energy has an equivalent mass. So light has energy, we all know that. So light, because of its energy, has an equivalent mass, and that is, one could say, what causes it to be affected by the force of gravity. So that is a different way of looking at it. So there are two ways of looking at it. They both give us different ideas, but they both essentially give us a simple handle on why light, despite being massless, photons, despite being massless, are very much affected by gravity. So that's a good question, very good question.